Hello everyone, welcome to this section. In this section, we are going to talk about polymorphism in C++. Polymorphism is one of the core concepts of object-oriented programming. It allows one interface to be used for multiple forms. In C++, it is achieved through function overloading, operator overloading, and runtime polymorphism via virtual functions and abstract classes. And they are useful because they allow the same function name or operator to work differently based on the context. So they are very useful in C++, and in this section we are going to focus on polymorphism in C++. In next videos, in the following videos, we are going to talk about coding exercises to discuss details of polymorphism in C++. Thank you for watching. Hello everyone, welcome to another lecture. In today's video, we're going to practice again runtime polymorphism. So runtime polymorphism occurs when a derived class provides its own version of a base class function. This is achieved using virtual functions, and it helps to write flexible and extensible code. So here we would like to write a program that demonstrates runtime polymorphism using a base shape class, and derived classes like circle and rectangles. So in order to do that, I'm having one base class called shape. So let me base class called shape. It is having a virtual function called draw, and it is going to print drawing a shape because it's a shape class. Then I'm having the first derived class 1 that is derived from the shape class, and it is having the same function name draw, and it is the override of the function of the base class, and it is going to print out drawing a circle. And I'm having the second derived class here, and this class is derived from the shape class again, and it is having the draw function again being override, and it is going to show the message drawing a rectangle. Okay, to summarize, one base class and two derived classes, and these two derived classes are having a function, each of them with the same name of the function from the shape class. And this draw function is a virtual function, and it is overriden in the first and second derived classes. Okay, now I'm having one main function here, and I'm creating a pointer called s from the shape class. Okay, a pointer s from the shape class is created. One object called C from the circle class is created, and one object called R from the second derived class, a rectangle, is created. Now, the address of the first object, which is from the circle class, is assigned to the pointer s. And then s is trying to call the function draw. But because it uses the virtual function, and the pointer now is pointing to the object C, which is an object from this class, it is going to call this function thanks to the virtual functions. And this message is going to be shown in the output. And then we are putting the address of the second object, which is the object R from the second derived classes. So now the pointer is assigned the address of the object of the rectangle class. Okay, and now the pointer again is calling the draw function, and now we expect that this function should be called and this message should be being printed out in the output. So we expect to see this message first and then this message. Okay, so let me run the code. So when we are running the code, we see that first this message is printed out, drawing a circle, and then drawing a rectangle is printed out. in the output thanks to the virtual functions, because we are using, when we are having the virtual functions, we are using runtime polymorphism. And basically runtime polymorphism occurs when a derived class provides its own version of a base class function. This is achieved using virtual functions. Okay, so if I comment the virtual keyword and the override keywords here, let me just comment these keywords. So when I comment the virtual function keywords, we see that even though the pointer s of the base class is pointing at the object of the first derived class and then pointing at the object of the second derived class, and then it is calling their draw functions respectively, it is not going to call this drawing a circle, this draw function, and it is not going to call this draw function. So therefore this message is not going to be shown in the output, but it is going to call this draw function, drawing a shape. So let me run the code. We see that here we have the same code, everything is the same, but we commented the virtual keyword, so our function is not virtual anymore, and we commented the override keywords. So now I still have a function, a pointer from the base class called s, and two objects here from the first derived class and the second derived class. Then I'm assigning the address of the object of the circle class to the pointer of the base class. Then pointer arrow draw should call this function because the address of the object of this derived class is assigned to the pointer of the base class. Okay. Therefore, when this pointer is calling the draw function, it should call this function, drawing a circle. But we see that it is not showing that message, and it is calling this draw function and drawing a shape. So when not using the virtual functions, because C++ uses static binding, it is going to call this draw function, and it's not going to consider that the pointer of the base class is pointing at the object of the circle class. Because the pointer is created from the base class, it is basically going to call the draw function from the base class. But when we are using the virtual keyword, we are telling the compiler, do dynamic dispatching, and therefore you must call the draw function of the circle class when the address of its object is assigned to the pointer of the base class. Okay, this is what happens when we are having the virtual keyword here, and when we are saying that we are using polymorphism runtime. So this is basically it, and it's not a very hard practice to be done. So try to practice it so you can understand it completely, and you can get used to using virtual keywords in your code where necessary. So it would be important, I think, and it's a good way to practice it and get used to its syntax and the way it works. Thank you for watching. Hello everyone, welcome to this lecture. In today's video, we are going to talk about virtual functions. Now, before I start giving you some explanation about virtual functions, let me give you an example in the code. So here, I would like to write a program that uses a virtual function in a base class and overrides it in a derived class. Okay, I'm having the virtual keyword here commented and override keyword here commented. So currently in this implemented code, we are not using virtual functions. I'm just having an example of what happens without having a virtual function, and then I'm going to uncomment these two keywords to discuss further. Okay, so I'm having a base class, and in this base class I'm having one function, and when this display function is called, the message saying that base class display is going to be called. It's going to be printed out in the terminal. And I'm having one derived class from the base class, and in the derived class also I'm having a function called display, which is having the similar name as the function in the base class. And here, when this function is called, the message derived class display is shown in the terminal. So when this function is called, base class display message is shown. When this function is called, derived class display is shown. Okay. Now in the main function, I'm having a pointer to the base class, and then I'm having an object created from the derived class here. And I'm assigning the address of the object from the derived class to the pointer. Okay? So far we know about this because, for example, we were having int a equal 10, and we could have int ptr equal the address of a. Okay, so far we know about this. This is what we learned already from pointers. We declare a pointer and then assign the address of one variable to that pointer. So I'm having a pointer of this class and an object of this derived class, and I'm just sending the address of that object to the pointer. Okay, and I'm having the pointer arrow display. So this pointer is now pointing at the function display. So this function display is called. Okay, but what is the output when I'm having a pointer of the base class and an object address that is assigned to that pointer of the base class? Okay, so an object of the derived class, a pointer of the base class, and pointer is pointing at the display function. So now pointer is calling the display function. So when I compile, we see that base class display message is shown. Okay, so this is the base class display shown here. This is the base class display shown here. So the problem is that we have a pointer of the base class and we have the object of the derived class, and the address of this object is assigned to this pointer. So when pointer is calling the display function, it should basically call this display, which is from the derived class. Why? Because in this line, I'm having the address of the object of this derived class assigned to the pointer. So we expect that the pointer should, when pointer calls the display function, should call this function. However, we see in the output, the base class display function is called. So basically, when we are not using the virtual keyword here, the function called is resolved at compile time based on the type of the pointer, which is the base here, and not object it points to. This is the object that it points to. Okay, so this is because C++ uses static binding, also called early binding, for non-virtual functions. This is why when I'm having the address of this object assigned to the pointer of the base class, still the pointer, when calling the function display, it is calling this display function from the base class, because C++ uses static binding for non-virtual functions. So this is what happens when we are not using the virtual keyword when we are declaring our for example functions here. Okay, so it is basically the function is resolved in at runtime based on the type of the object being pointed. Okay, so now if I include having the virtual keyword, if I include these two, so when you have the virtual keyword in the base class function, when you want to override it, you need to have the override keyword also in the derived class function here as well. So when the virtual keyword is indeed included, dynamic dispatch is started in C++. So dynamic dispatch occurs. This means that the function called is resolved at runtime based on the actual type of the object and not the type of the pointer. Okay, so what I mean is that previously we saw that when we were not having the virtual function and override keyword included, although the pointer b from the base class was pointing at the object d from the derived class, it was calling the display function from the base class because C++ uses a static binding for non-virtual functions. However, when you have the virtual keyword and override keyword included in the base and derived classes respectively, the pointer b is going to point again at the object d. However, at the runtime, the dynamic dispatch occurs and it makes sure that it is going to call the correct display function. So when I run this code now, we see that derived class display is being printed out in the output. So the lesson of this video is the following. When we are not using virtual functions, the pointer, even if the pointer is pointing at the object of the derived class, it is not going to call the correct display function when we are having the same name functions with the same name in both classes. However, if we would like to make it correct, we need to include virtual keyword before the function name in the base class and the override keyword after the function name in the derived class. This way, we are letting dynamic dispatch occurs, so we make sure that when the pointer b is pointing at the object d, and when using this pointer we are calling the display function, the correct display function is called, which is this one, because the pointer of this class is pointing at the object of this class. So when display function is called, it must be this function. Okay, so using virtual function we can make it work like that. Thank you for watching. Hello everyone, welcome to another lesson. In today's video, we are going to talk about function overloading. So function overloading allows multiple functions with the same name but different parameters, and the compiler determines the appropriate function to call based on the arguments. So it helps us to achieve cleaner and more readable code, and it allows the same function to handle different types or numbers of inputs. So we would like to write a program that demonstrates function overloading for an add function. To do that, we are having one int main function and we are having two functions here. Let's say we are having overloaded functions. Why I'm saying that overloaded functions? Because the name of the both functions are the same. So this function name is add and this function name is add. However, the first function, it is returning an integer and it is accepting two arguments that are integer types, and it is going to return a plus b. So the first argument plus the second argument. The same name function is the second function. So the second function is having the same name, which is add again. However, it is returning a double and it is accepting two arguments to be double, and it is going to return the sum of a and b. So a plus b is going to be the result of this function. So these two functions are basically doing the same thing, but the first one is dealing with integers and the second one is dealing with doubles. So in the int main function, I'm having a message saying that sum of integers, I'm calling the function and I'm passing two numbers as the arguments, 2 and 3. And then in the second line, I'm counting sum of double, and then I'm calling the add function again. and I'm passing two double numbers for the function. However, I am using the same function name, so add and add. But because this function is accepting double and this function is accepting integer, when I'm calling the add function and I'm passing two integer numbers as the arguments, the compiler is going to understand that I'm talking about this add function and not this one. Why? Because I'm passing two integer values as to be the arguments that are here defined to be integer in the arguments of this add function. Okay? And in the second line, when I'm calling the add function again, I'm not passing an integer number, but I'm passing two double numbers. And because they are doubles, because they are having decimals, the compiler itself is going to understand that I'm talking about this add function and not this one, because I'm passing double numbers as to be the arguments. So this is what we call function overloading. We are using the same name for two different functions. Basically, they are doing the same thing, but they are dealing with different arguments, or let's say different types of arguments and parameters. So let me run the code. Okay, so when I run the code, I have the add function being called here with number 2 and 3. So when I'm calling the add function, the compiler understands that I'm giving it two arguments that are integer values. So it is going to call this function, this integer function. And then when it is calling this function, it is going to have the a plus b, which is the output 5. And then I'm going to have another add function being called here, but because they are double numbers, it is going to come to this function and add those two numbers together. And then the output would be 6.05. So basically, this is the concept of function overloading. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about compile time polymorphism. In particular, we are going to talk about overloading functions. We would like to write a program that calculates the area of different shapes, circle, rectangle, and triangle, using function overloading. So here we are having a class called shape. In the public part, we are having three functions. And the functions name are the same. So all of them are area, but there is a difference between them. So the first area function is going to return a double, and it is accepting only one double value as argument. It is going to calculate the circle area for us. It is going to compute the area of a circle with this formula and return the output for us whenever this function is called. The second function is having the same name, however, it has two arguments in parentheses. So whenever we call the function area, if we pass two arguments, this function is going to be implemented and activated. If we have only one argument in the parentheses, this function instead is going to be activated. And this function is going to calculate the area of a rectangle for us by multiplying the length and width that are passed in the argument of this function. And this function is going to return the computed output. And finally, in order to compute the area of a triangle, here we are having again the function called area, and then we are having three arguments here in the parentheses. The first two ones are doubles, they're called base and height, and then the last one is a boolean, and the name is triangle. So if the last argument, which is of boolean type, equals true, we're going to calculate the area of this triangle that follows this formula for us. Okay, so this is how we can have function overloading in C++. The names of the functions are the same, however, in parentheses the arguments are different. So this accepts only one argument, this one 2 arguments, and this one 3 arguments. So let us move to the int main function. Here I'm creating an object from the shape class. So the name of my object is shape, but I can change it to S. I would say S is easier. So I am creating an object called S from the shape class, and I'm calling these areas functions. However, in order to calculate the circle area, I'm calling the area function using the object S of the shape class, but I'm passing only one argument in the parentheses. Because I'm passing only one argument, it is going to activate this function, and this function is going to return me the output, which is the formula for calculating the area of a circle. Then in the next line, I type down the message to the user, a rectangle area. And for the rectangle area, we are using the object again dot area. So I'm typing down the name of the function. However, I'm having 2 arguments in the parentheses that is passed to the area function. Because 2 arguments are being passed, this function is going to be activated. So this area, because there are 2 arguments in the parentheses for this area function, and it is going to basically calculate the area of a rectangle for us. And finally, in the triangle area, we are calling the area function with 3 arguments. So the first one is the base, the second one is the height, and the last one is true. We are saying that yes, it's a triangle, so go ahead and calculate the area for us in this function. So when I run this code, we see that circle area is calculated to be 78.5. We see the rectangle area is 24, came out of this formula, and then triangle area is 7.5. So this is how we can have function overloading in C++. We have functions, different functions with the same name, but they're having differences in the arguments that they're accepting to be passed to them to do the calculation. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about runtime polymorphism using virtual functions. Here we would like to write a program where a base class shape defines a virtual function draw. Derived classes circle, rectangle, and triangle override this function to print different shapes. Here is my base class. It is called shape, and it has one virtual void function that is called draw. And whenever this draw function is called, it is going to simply print this message, drawing a generic shape. Then we are having the first derived class called circle, and it is derived from the shape class. As you see, using the colon, we're doing this. Then we are having the draw function, which is of void type, and it overrides the virtual function in the base class. So this is why we're using the override keyword. And whenever this draw function is called, it is going to print drawing a circle message in the terminal. Rectangle class is our next class. It is derived again from the shape class. It is going to override the draw function in the shape class. This is why we are having the override keyword, and whenever this draw function is called, we are going to have the message in the output drawing a rectangle. And finally, we are having the last derived class. It is also derived from the shape class, and it has again the draw function, which overrides the draw function in the base class. And whenever this one is called, it is going to print the message drawing a triangle. Now in the int main function, we are creating a pointer to the shape class, which is our base class. And then we are creating object from the circle class. Okay, so the circle class object, let me call it C here. So we are creating an object called C from the circle class, which is derived from the shape class. And now we are going to assign the address of this object to the pointer of the shape class. Okay, so this is what we are doing here. So we are assigning the address of the object of the circle class, which is a derived class from the shape class, to be assigned to the shape pointer, which is the pointer of the shape class. Okay, then we are having this pointer pointing at draw function. So shape arrow draw. This draw function is going to activate this draw function. Although it is the pointer of the shape class, it is not going to call this draw function. Why? Because we created an object from the circle class and we assigned the address of that object to the pointer of the shape class pointer. Okay. Then when shape class is pointing at the draw function, it is going to call this draw function. Similarly, what we do here, we are creating an object from the rectangle class, which is derived from the shape class. Then we are assigning the address of this object to shape, which is the pointer, of the shape class. And then shape pointer is now pointing at the draw function again. So shape arrow draw. In this example, because before calling the draw function, we are assigning the address of the object of the rectangle class, it is going to call the draw function in the rectangle class. And finally, here we are having an object being created from the triangle class, which is called T, and the address of this object is assigned to the pointer shape. Then now shape arrow draw. So now we are again calling the draw function, and now this time the draw function in the triangle class is being activated. So when I run this code, I expect to first see drawing a circle, then drawing a rectangle, and then drawing a triangle. When I run this code, we see that we are having drawing a circle, drawing a rectangle, and drawing a triangle. So this is how we can have runtime polymorphism. However, if I remove this virtual keyword and also remove these override keywords and I save, when I run this code, we see that in the output we are having drawing a generic shape 3 times being printed. So only this draw function that is from the shape class is going to be activated 3 times. Although we are giving the address of the object of the circle class to be assigned to the pointer, it is when pointer is calling the draw function, it is calling the draw function of the shape class, because shape is a pointer of that class and it is not going to update the pointer when it is calling the draw function at runtime. So this is why we call it runtime polymorphism. Shape pointer is created for the shape class. This is what the compiler knows, and it is not going to update the pointer address when we are assigning the object of the another class to this pointer. So when we are not having the virtual function, this is how the behavior of the compiler will be. It is taking the pointer of shape and it says, okay, shape is the pointer of the shape class and it is calling the draw function. And because shape is the pointer of the shape class, it means that we are calling the draw function from the shape class. However, this is not the runtime polymorphism, because it is not going to update the pointer that it is pointing to the address. It is storing the address of an object of another class. In order to update the pointer, as we learned in this section, we need to have the virtual functions with overriding keywords, so the compiler would understand that now that we are having, yes, we are having a pointer from the shape class, but we are reassigning this pointer in real time, so the compiler needs to update it before calling the draw function. This is why we need the virtual function. So if I run the code one more time, we see now we are having the runtime polymorphism, and this draw function drawing a generic shape is not being printed out in the output, and now the compiler is understanding that we are overriding the draw function in the base class. Thank you for watching. Hello everyone, welcome to this lecture. Today's video, we're going to talk about abstract classes and pure virtual functions. So abstract classes contain at least one pure virtual function. But what is the usefulness of abstract classes? So imagine we are developing a payment processing system where different payment methods, for example, credit card, PayPal, and Bitcoin, is available. So different payment methods need to process payments differently. So by using an abstract class, we define a common interface for all payment methods, ensuring each implements its specific functionality. So for example, in this video, we are going to give you a coding exercise to know how the pure virtual function is declared and what an abstract class means. In the next video, I'm going to give you a more practical example of how this abstract classes concept can help us in, for example, different practical examples. In this video, we are going to learn only how to declare it and how to use it. In the next video, I'm coming up with some practical examples so you see how tangible it would be to use abstract classes in real world situations. Okay, so now only the declaration and its usage. So I'm having one class that is called animal. The animal class is having one virtual function called make sound, and this function equals 0. When this equals 0, it means that it's a pure virtual function. It's a sign for us to understand a pure virtual function when a function equals 0. Therefore, because we have at least one pure virtual function in this class, we call this class an abstract class. This is how we call it then. We are having the first derived class 1. So let me also type down here base class. And the first derived class is called dog. It is derived from animal, and it is having the same function. So make sound, a function with the same name, let's say. And it is using the override keyword because obviously we are using a virtual function. And then it is showing the message from dog class. Okay. And we are having the second derived class 2. And in this derived class, the class is called cat, and it is derived from the same animal class, base class, and it has a function called makeSound, which has the same name as the one in the base class, and we are using the override function keyword because we are having a virtual function, and it is showing the message from cat classes. Okay. Now in the int main function, I'm creating a pointer of the base class animal, and then I'm having an object of the dog and another object of the cat class. Okay. First of all, I'm putting the address of the D, which is the object of the dog class, to be assigned to pointer A. And then in this pointer A is calling the make sound function. So we expect that because we are having a virtual function, we expect that this make sound function will be this make sound function, because now the pointer of the base class is pointing at the object of the dog class. Therefore, we are having a virtual function as well. Therefore, it must call this make sound function. So this message should be shown in the output from dog class. Then we are assigning the address of the object C, which is the object derived from the second derived class cat, to be assigned to pointer A. And then this pointer A again is calling this make sound function. And now, because the address of an object from the derived class cat is assigned to the pointer of the base class animal, we expect that when we call this make sound function using the pointer a, this time it is going to call this make sound function because the pointer of the base class is now pointing at the object of the cat class and we are using a virtual function. So this function make sound should be called and we expect to see this message in the output cell. So when I run the code, okay, we see that from dog class and from cat class. So this is the output that we learned already that we expect to see using polymorphism runtime. But the point to this video was to understand that this is a pure virtual function because it equals 0. And therefore, this animal class is called an abstract class because it has at least one pure virtual function. In the next video, I'm going to provide a practical example of the usage of the pure virtual functions and abstract classes. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about polymorphism with abstract classes. We would like to write a program where an abstract base class animal has a pure virtual function called makeSound. And then derived classes called dog, cat, and cow override this function to print their respective greetings. Here is my base class called animal. We are having a virtual function, a pure virtual function called makeSound. And how do I know that it's pure? Because it is equal to 0. Then we are having a class called dog. It is derived from the animal class. It has the same function name called makeSound, and it's going to override the virtual function makeSound in the base class and print whenever this makeSound is called. It is going to print dog says hi message. Then we are having another class called cat. It is derived from animal class. It has the same function name, and whenever that it is called, it is going to show this message cat says hi in the output. And then we are having the cow class derived from the animal class or the base class. It has the same function name and it is going to override the make sound virtual abstract pure virtual function. And whenever this make sound function is called, it is going to show this message cow says hi. Now in the int main function, we are creating a pointer called animal from the animal class. And then we are creating an object called dog from the dog class, and we are assigning the address of that object to the pointer animal. Then the pointer animal using the arrow is pointing to the make sound function. So we are calling the make sound function. We are having the pointer arrow make sound. Now because we are having a virtual function, we expect to see this function make sound from the dog class to be activated. Why? Because the address of the object of that class is assigned to the pointer. Then we are having another object called cat created from the cat class, and the address of this object is now assigned to the animal pointer, and the pointer is pointing at the make sound function one more time. So animal arrow make sound. And now we expect to see this make sound function to be activated because we assign the object address of the cat class to the pointer. Although the pointer is a pointer of the base class, we assigned the address of the object of one of the derived classes to that. So it is going to call the make sound function from the derived classes because we are having a virtual function. Okay. And we expect to see this message in the output. Cat says hi. And finally, we are creating an object cow from the cow class, and its address is assigned to the animal pointer. And pointer animal is pointing at the make sound function. And now we expect to see the activation of this function and this message being shown in the terminal. So when I run this code, we see when for the first time when we call the make sound function, it is going to say dog says hi because the address of the object from the dog class was assigned to this pointer. So this one is desirable. This is what we expected. And then it says cat says hi because in the second time that we are calling the make sound function, before that, the address of the cat object from the cat class was being assigned to this pointer. Therefore, we expect to see cat says hi, so this make sound function is activated. So this is what we expected as well. And finally, we call this make sound function one more time, and it says cow says hi. Before calling this function, we updated the pointer, and now the address of the cow pointer from the cow class is assigned to this pointer animal. And now animal is pointing at the make sound function. We expect that this make sound function will be activated. Therefore, cow says hi. And this is the reason. The reason of this output is because we are having a virtual function. In previous examples, we showed that if it's not a virtual function, and we remove this virtual keyword and override keywords here, it is going to, when we are having a pointer animal from the animal class, whenever we are calling the make sound function, it is going to call this make sound function. And it is the compiler is not going to see the updating of the address that is assigned to this pointer, so it's not a runtime polymorphism. It is the time that the assignment time that the pointer is from that class. Therefore, whenever this pointer is going to call the make sound function, it is going to call the make sound function from the base class because it is a pointer of this base class. We showed this in the previous examples, but I just wanted to give you another reminder of that. But thanks to the virtual functions and the override keyword here, when we are updating the pointer with the address of object of another derived class, it is going to call the function that is inside that derived class. Thank you for watching. Hi, welcome back. Now in this video, we are going to talk about runtime polymorphism. We would like to write a program where base class employee has a virtual function calculate pay, derived classes full-time employee and part-time employee override this function to calculate pay differently. Here is my base class called employee. It has a virtual function called calculate pay, and as you see, it has a pure virtual function because this function that is virtual equals 0. Now we are having a class called full-time employee. It is derived from the employee class. It has one variable called monthly salary. And then in this class, we are having a constructor, and it is going to accept the salary as the argument and assign this salary basically to the monthly salary variable. And in this class, we are having a function called calculate pay, which overrides this virtual function here. Okay, and basically it is going to return monthly salary. So whatever that is assigned to this variable, it is going to return it. And this variable is assigned using the salary, which is the argument of the constructor of this class. So whenever we are creating an object from this class, automatically we are required to have one argument as salary, and this constructor is going to assign that salary to the monthly salary variable, and whenever this function from this class is called, it is going to return that value. Then we are having the second class called part-time employee. It is derived from, again, the employee function. It has two variables, hourly rate and hours worked. These two variables are used in our constructor. So we are having a constructor for this class. And how do we know that it's a constructor? Because the name is the same name as the class. It accepts two variables, rate and hour. So whenever we are creating an object of this class, automatically we are calling the constructor, because whenever we are creating an object of this class, we must have two arguments in parentheses, the first one for rate and the second one for hours. And rate is going to be assigned to hourly rate, the first variable, and hours is going to be assigned to hours worked to the second variable. And whenever the function calculate pay that is going to override this virtual function from the base class, is called, it is going to calculate the hourly rate multiplied by hours worked and then return the output for us. Let me illustrate it with an example. Here in int main function, I am creating an object called full-time from the full-time employee class. So this is the full-time employee class, and I'm creating an object called full-time. In parentheses, I have one number. What is this number? This is the number that we need to have because we have a constructor for this class. So I'm creating an object, and at the same time, I am initializing my monthly salary variable. How? When I'm creating an object called full-time, this 3000 is going to be assigned to this salary, and this constructor is assigning that salary to the monthly salary, which is the only variable of the full-time employee class. Okay, so this is what is going to happen for the moment. Then we are creating another object called part-time, but this time from part-time employee class. We are this time having two arguments. Why? Because we have a constructor with two arguments. The first one is the rate, and the second one is the average. So for example, this guy is going to receive $20 per hour, and he worked for 120 hours. So this rate 20 is going to be assigned to hourly rate variable, and this hours like 120 is going to be assigned to hours worked, the second variable. This is the job of the constructor. Now, we would like to call the calculate pay. Well, we use the object of the full-time employee class, which is full-time, dot calculate pay to call this function. And this function is basically going to return the monthly salary. And monthly salary is receiving its value from the salary, and salary is the argument of the constructor. So when we are creating an object of this class, we are having it in the parentheses, which is 3000 here. Okay. Then we are using the object of the second class, which is part-time, and calling the calculate pay function. And calculate pay function this time is going to activate this calculate because we are using the object of the part-time employee class. Okay. And now it is going to calculate hourly rate multiplied by hours worked. Basically, it is going to calculate the salary of the part-time employee, and it is going to be calculated based on this. Okay. And how we know about hourly rate and hourly worked, these are the values that are getting their numbers from rate and hours, and rate and hours are the two arguments of this constructor. So when we were creating an object of this class, we were passing two arguments that were 20 and 120. So when I run this code, I expect to see 3000 and also the multiplication of 20 and 120. So here, 3000 for the full-time employee, because it is basically going to return the monthly salary, which was initialized to be 3000. Then the part-time employee is getting 2400 because he or she worked for 120 hours, and for each hour we are giving the person $20. So the calculation of the calculate pay function will be this one, hourly rate multiplied by hourly work, meaning that 120 is multiplied by 20, and then the output is 2400. So this is how we can have a runtime polymorphism, and we learned how to override a virtual function, especially that this class is an abstract class because we are having a pure virtual function here. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we are going to provide a practical example of the usage of abstract classes. So imagine we are developing a payment processing system where different payment methods like credit card, PayPal, and Bitcoin need to process payments differently. By using an abstract class, we define a common interface for all payment methods, ensuring each implements its specific functionality. To do that, I'm having one base class called payment method, and this payment method is having one virtual function called process payment, and it's a pure virtual function because it equals 0. Therefore, it is an abstract base class. Okay. and it has one argument called amount. So now I'm having the derived class for credit card from the payment method here, and this credit card class is having process payment function, similar name to the one here, and it is having one argument, and it overrides the function with the same name from the base class, and it is going to print out processing credit card payment of, and then the amount that is passed as the argument to this function is going to be printed out in the output. Similarly, we are having the class called PayPal. It's derived from this payment method class, and it is having a function with the similar name of the base class function, and it is having the amount argument as well. So we use override because we're going to override the virtual function from the base class, and it is showing the message to the in the output processing PayPal payment of, and then we are having the amount here that is passed to call this function. Finally, we are having one class called Bitcoin. It is derived from the base class again. It is having the same function name as the base class, and it is showing the processing Bitcoin payment of, and the amount that is passed to call this function is going to be printed out in the output. So we are providing a common interface for different payment methods here. In the int main function, I'm creating a pointer called payment, and the payment pointer is created from the base class called payment method, okay, this abstract class. Then I'm creating objects from my derived classes, CC for credit card, PP for PayPal, and BTC for Bitcoin. Okay. First of all, I'm putting the address of the credit card object to the payment pointer, and using the payment pointer, I'm calling the process payment function that is going to be called. So this one is the one that is going to be called because the pointer of the base class is now pointing at the object of this derived class, and we are using virtual functions. Therefore, this process payment function should be called, and we are calling the function using this argument. So that amount that is shown in the parentheses as the argument is 100.50 now here. Okay, so we are calling that process payment function using this argument, and the compiler comes here to execute this block of code. So it calls this function. So we see that in the output processing credit card payment of $100.5, and we're having the dollar sign here. Okay. Then I'm doing the same thing. I'm assigning the address of the PayPal object to the payment pointer, and using this pointer, I'm calling the process payment. And I expect to see the output of this function here, this process payment, because now the pointer payment is pointing at the address of the object derived from this derived class called PayPal, which is PP here. You see that the address of the PayPal PP, the address of the PayPal object, which is PP, is assigned to the payment pointer, and using the pointer, we are calling this process payment function, and this function should be called because we are having a base class virtual function, okay? And the amount that is passed to this to call this function is 200.75. So we expect to see in the output processing PayPal payment of 200.75. And finally, I'm putting the address of Bitcoin class object, which is BTC, to the pointer payment, and then using the payment pointer, I'm calling the process payment, and I expect that this function should be called using this argument. So I'm having the message in the terminal saying that processing Bitcoin payment of $350. Okay, so the benefit of using the abstract class is that we are having one common interface. So the payment method class ensures all payment types implement the process payment method. Using a pointer to the base class, which is this one, we can handle different payment types uniformly, and adding a new payment method like Apple Pay is easy, and we just need to have another derived class from the main class, from the base class payment method, and implement the process payment function very easily. So let me run the code. So as we expected, 3 output is printed out in the terminal because we are calling the process payment function 3 times. And the first line that is printed, it's the processing credit card. Why? Because we assign the pointer to point at the address of the CC object that is created from the credit card class. So this is what that function was supposed to print out for us, processing credit card payment of 150, and 150 comes from this argument that we're calling the function using this number. And then we are having the PayPal payment. This is the second call. And then we are having the Bitcoin payment. This is the third call. Okay. So in this example, we learned that using an abstract class, we can provide a common interface and we can have different payment methods as to be different derived classes from the base class. And when the base class is using pure virtual functions, we can have unique functions being implemented in each derived classes for as to be different payment methods. And it is easy to add a new payment method like Apple Pay when we are having an abstract class, as you saw in this example. Thank you for watching.